Well, hello everybody. This is Mr. Taylor, and we want to continue with our Unit 8. Let's take a look at 8.8D. Now, it's going to be a little fast paced, so please make sure that you download, look at the actual PowerPoint. Make sure you also download the PDF file that's in Google Classroom and work the exercises. Remember, when you work those exercises, you get actual, like a pass. Well, actually, it's not a pass. You work the exercises, you get a 100 for assignments that we're handing out, and you can use those for any assignments. All right, so we want to look at how we use informal arguments to establish facts about angle sum and exterior angle of triangles. Now, this is something that you create an equation with in the 7th grade, so it should be a familiar topic, and we'll try. We're not going to be able to get all 17 of these slides into one setting. That's a little too long, so I'm going to break it up probably in about 2 or 3 sessions. So let's get started. First thing we want to be able to address, as always, is our definitions. So the first definition we want to take a look at is a degree. So the author says a degree is the measure of an angle where each degree represents 1/360th of a circle. Unit measure labels as degrees or with symbols of the degree symbol. So when we look at our unit measure, if it gives us, say for instance, 42 degrees, then that measure would be this little upward 0. Or we could just say 42 degrees. Adjacent angles are two non-overlapping angles that share a common vertex and exactly one ray. They share a common vertex and exactly one ray. Let's take a look at an example. Here we have angle A and angle B. Well, the author tells us that angle A and angle B are adjacent angles because these two angles are non-overlapping, this angle and this angle, non-overlapping, and they share this common vertex. And there's only one ray. Now, here we see angle 1 and angle 2. Here's angle 1 and here's angle 2. They are adjacent because they're sharing one ray. Okay? They're not overlapping. Now, if we look at angle 2 and angle 3, they are adjacent because they're sharing one ray and with a common vertex. Now, if we take a look at angle 1 and angle 3, well, they're not adjacent because here angle 1 and angle 3 is also sharing angle 2. Okay, so they're not, it's not a common vertex for just one of the angles, so they are not adjacent. More definition. Complementary angles. These are two angles whose degree measure have a sum of 90 degrees. So if we look at this triangle, you have one angle, here's another angle, and here's another angle here. So this triangle has 3 interior angles. The total sum of this 3 interior angles, well, two angles whose degree measure has a sum of 90 degrees. So we're talking about 2 angles. So if we take this angle and this angle, or if we take this angle and this angle, we say that these 2 angle measure have a sum of 90 degrees. Now, supplementary angles are two angles whose degree have a sum of 180 degrees. Okay, so in this case, it would be, of course, we know that a triangle is not going to have two 90-degree angles because you have three angles involved, and the measure of this triangle is 180. So supplementary angles are two angles whose degree measure a sum of 180 degrees. Now, a triangle. We've been talking about triangles, but we can see here that a triangle is a polygon with three sides and three vertices. 1, 2, 3 sides, 1, 2, 3 vertices. And the interior angles of a triangle. These are angles that are inside of this particular triangle, formed by two sides of the triangle. So this interior angle is formed by this particular side and this particular side. This interior angle of the triangle is formed by this particular side and this particular side. And of course, this particular angle is formed by this particular side and this particular side. So exterior angles, now we just looked at the interior part. Exterior angles of a triangle are angles that are outside of the triangle, between one side of the triangle and the extension of the adjacent side. So we're looking at this triangle, and here's our extension, here's our extension, and here's our extension. So my angle, exterior angle of this triangle on the exterior is here, it is here, and it is here. These are the exterior parts. I hope I'm not losing you. And we're not going to go too much further with this to make sure we get some clarity. So, informal arguments that we use, and remember this is what this session is about, is the arguments. You get to the more proofs and things when you get to geometry, but this is 8th grade math, and we're just going to look at some arguments. So it says the sum of the measure of the interior angles of a triangle equals 180 degrees. That's what I said earlier. You create a triangle, then we're familiar with our famous 60, 60, 60, which is an equilateral triangle. And if you add 60, 60, and 60, and these are the interior measure of these triangles, you get 180 degrees. So if we have a 90-degree triangle that we've been talking about, if we have a 90-degree triangle, which is where A and B meet, then the other angles must be 90, 180 minus 90, and then you have to divide by 2. So they can't be but a total of 30, 30. And mostly for a right triangle, that's what we get. So just keep in mind, when we're dealing with the interior measure of this triangle, it has to equal 180 degrees. Now, adjacent interior and exterior angles are complementary. Adjacent interior and exterior angles. If you look down here with me, what this is telling us that if these are, well, adjacent and exterior angles create a supplementary pair, and that's going to equal to 180 degrees. So I misspoken. They are supplementary. So if they're supplementary, when you add these two angles up, you must get 180 degrees. So if the interior is 37.4, to get the exterior, you're just going to subtract 180 minus 37.4, and that's going to give you that exterior. That's when you have the adjacent. We're talking about right next to each other. Exterior, interior measure will equal 180. The same here. You have an 82 degrees interior angle. Well, we need to know, well, what is the exterior angle? Then all we got to do is subtract 180 minus 82.2. And that's going to give us 91.8. Okay, now we have to think here. let's just hypothetically say we don't have this particular angle. We don't know what this angle is. But we have solved here and got 37.4. We have solved here and got 88.2. So the only thing we need to do now is add these two up. This is what the author did here. 88.2, 37.4, and we'll get 125.6. Well, if we subtract 125.6 from 180, then we will get 54.4. So remember, all three of these angles add up to give us 180 degrees. All three of these angles. So again, we were talking about when you look at these adjacent interior and exterior, then they have to add up to 180. And the same thing here, these particular two angles have to add up to 180. And then, of course, these two angles must have to add up to 180. I mean, you just take your time and go over. We're going to spend a lot of time, as much as we possibly can. We don't have that much of a time. We do have a deadline on this, but we'll spend as much as we possibly can to make sure that we're clear on this. Okay, says an exterior angle is equal to the sum of the two adjacent interior angles or the remote interior angles. Now, this is what we just finished talking about here when we said that they were equal to this sum. The sum of the measure of the exterior angle, one at each vertex of a triangle, equals 360 degrees. The sum of the measure of the exterior angles, one at each vertex, equals 360 degrees. Well, that should be because you have a sum of 180 here, and you have a sum of 180 here, and 180 plus 180 is 360. Or we could go this way, a sum of 180 here, and a sum of 180 here, and these will still equal 360. A sum of 180 here, and a sum of 180 here, and guys, we'll still get 360 degrees. So we want to look at now at some equations that represent the relationship between interior and exterior angles and determine a missing angle measure. Now, what we're going to probably do is we're probably going to cut it off at this particular slide because this is a whole lot to digest. And we really don't want to go too far. You might want to get your notes and make sure you look over this and see exactly what we are asked to do. So probably I'll see when we get to the next one. So here's an example. The sum of the interior angles of a triangle equal 180 degrees. So here they took 37.4, 88.2, and 54.4, and it gave us 180 degrees when you add all these up. 4 and 4 is 8 plus 2, and then just go ahead and put those on your Inspire and add them up, or your TI-84. Okay, another equation. The sum of an interior angle of a triangle and its exterior angle measures 180 degrees. So we have 37.4 plus 142.6, and that will give us 180 degrees. Or we can just easily say, if we know that this is 180, we can say 180 degrees minus this angle is going to give us this angle. Or we better yet, we can say 180 degrees minus this angle is going to give us this angle. Okay. The sum of a measure of the two non-adjacent angles, or interior, let's go make sure we follow it correctly. The sum of the measure of the two non-adjacent interior or remote interior angles of a triangle must equal the measure of the non-adjacent exterior angle. So let's see what they mean when they say non-adjacent exterior. So we have 88.2. That is, then we have 54.4. These two angles. They're not adjacent. These are adjacent. These are not adjacent. These are interior angles. So if we add these, okay, so they must equal the measure of the non-adjacent exterior angles. So if we add these two, they must equal to the non-adjacent, not here, they must equal to the non-adjacent exterior angles. So we add these two angles, they must equal this angle. Okay, well, what happens if we add these two? Let's take a look. I guarantee you it's going to equal to 125.6. So I'm taking my little handy calculator. I don't know about you, and I'm going to take non-adjacent. So I'm going to take, what am I taking here? 37.4 plus 88.2. 37.4 plus 88.2, and it gives me this particular angle. So these two must give me this one. These two must give me this. Now, the sum of the exterior angles of a triangle equals 360 degrees. The sum of the exterior angles of a triangle. So if we have 142.6, that's an exterior angle, 91.8 is an exterior angle, and 125.6 must equal 360. Totally different from the interior. The interior says it has to equal 90. The exterior angles of a triangle equals 360. Okay, so let me take a look at slide 6 and see, do the example, and it doesn't. So let's go ahead and call it a day right here, and then we'll come back and take a look at the congruent angles and how they're set up. And we should just know from actual definition that congruent angles are angles whose measure are actually the same. All right, so we got a mouthful there, but I guarantee you listening, taking notes in class, using your class notes, and we'll be fine. This is Mr. Taylor, and I'll see you soon.